So we have a question from this paper, CR.RO, question number 18, subsection 2. Can you read the question? Three light rays, red, green, and blue, are incident on the right-angled prism ABC at face AB. Okay, so this is the prism ABC. So this face is AB, and this face is BC, and the last one is AC. What is the question? The refractive indices of the material of the prism for red, green, and blue are 1.39, 1.44, and 1.47. They have given you the refractive indices of red color. Red color is what? 1.39. Then what? Red color. Green color is what? 1.44. And blue color is also given 1.47. And they're asking what? Trace the paths of these rays, reasoning out the difference in their behavior. I did this by another method earlier, but I'm trying another method this time. But using this method, we have done questions in the past. Okay. Now tell me, what is the condition for TAR to happen? TAR happens if, what is the condition? You know, there are two conditions, right? Number one, ray must go from a denser medium to a rarer medium. The ray must go from a denser medium to a rarer medium. Second condition is what? Angle of incidence must be greater than critical angle, right? I'm using that condition. I repeat one more time. We got how many rays? There are three rays. The first one is blue, second one is green, third one is red. Okay. So as they are falling normally, for normal incidence, there is no bending. The ray will go straight as such. I told you yesterday, we have done many questions like this, if you remember, right? For normal incidence, there is no bending at all, right? For normal incidence, the ray will go straight and hit the second surface, right? How about the second one? Second one also falls at, falls at 0, that is normal incidence, that is also going straight and hitting the second surface, right? Third one, same is the case with third one. Look at the red one. Red one is also going straight. It is going straight and hitting the second surface as shown. Got it? Right. Now, look at this. What is the condition for TAR? Angle of incidence must be greater than the critical angle, right? So let us find the angle of incidence. I'm drawing the normal here. This is the normal. All right. And tell me, this angle is given as 45 degree. How do we know? Right angle isosceles prism. Isosceles means what? This is right angle. So isosceles means this will be 45, this will be 45, right? Correct. So if this is 45, this is already 90. 90 plus 45, 135. So that makes this one what? 45 degree. Am I correct? So this angle will be what now? This is 90 degree, right? Because I have drawn a normal here. Am I correct? This is a normal. So if that is 45, that will make this angle 45, which is my angle of incidence. Why? It is the angle between incident ray and the normal. The angle between incident ray and the normal is called angle of incidence. So I got this condition here, angle of incidence 45 should be greater than critical angle. Correct? I take sine on both sides. Sine 45 is greater than sine of critical angle because angle is directly proportional to the sine function. The more the value of angle, the more is sine function. Got it? So when 45 is greater than C, I could say sine 45 is greater than sine C. Then what is sine 45? 1 by root 2. What is sine C? The only equation for sine C is 1 by n involving refractive index. Correct? If 1 by root 2 is greater than 1 by n, tell me what? When you take the reciprocal, you have to reverse what? The inequality symbol, right? Look at this. 5 is greater than 2. If you take the reciprocal, 1 by 5, take the reciprocal, 1 by 2. Which number is greater? 1 by 2 is greater, right? So 1 by 2 is greater than 1 by 5. Correct. So when you take the reciprocal, you must reverse the direction of inequality symbol. Got it? So let us put it over here. Tell me what? Root 2 will be less than n. Okay. So which all colors will undergo TAR? The colors whose refractive index is greater than root 2. Correct. Root 2 is what? 1.414, right? Right. So greater than 1.414. Tell me. Green. Green is greater than green. Green's refractive index is greater than 1.414. Even blue's refractive index is greater than 1.414. So both those colors will undergo TIR. Both those colors. Blue will undergo TIR, so that will come straight down. Okay. Green will undergo TIR. That also comes straight down like this. Okay. Then what about red? Red will not undergo TIR. Why? Why? The red color's refractive index is 1.39, which is less than root 2. It has to be greater than root 2, right? If TIR is to happen. Am I correct? So instead of total internal reflection, that ray undergoes refraction. So this is a much easier method than the one we discussed in class. Understood this? Write this down. All of you? Everyone understood this?